All right, everybody. So we're going to look at, this is Horner, and we're going to look at 2005 AP Physics free response question. This is number 2, and what we want to look at for this one is just making sure that we can draw some diagrams. There's really not a lot more to it other than drawing some diagrams and then just making sure that we can solve for one of the components of tension. So here we go. It's got a simple pendulum. You'll notice that it is mass. It does have a mass to it, 1.8 kilograms. And we know that the length of this string is about 2.3 meters. We know the angle here is about 30 degrees. So they want us to go ahead and try to draw the free body diagram for the above thing. So we're just going to look at just this part right here because that's really all we need. Always, 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 since we're on Earth, we're going to draw one straight down. That is the weight, or mg, for that mass. We have a tension going in this direction, and we're going to call that the horizontal tension. And then we've got another tension following the rope, and we're going to call that just T. The angle that we have here is about 30 degrees, because the angle here is 30 degrees. So they told us this angle. These are complementary angles, so they are exactly the same. And that's really all you need. You get 1 point each for making sure that you have tension going to the right and tension going up to the left. So you get 1 point for that and 1 point for mg. So I know it seems like it should be 3 points, but for some reason in the year they did this one, they only gave it 2. So I'd probably end up giving it 3. Let's move on down. It says calculate the tension in the horizontal string. So in order to do that, let's go ahead and redraw our diagram here. This is one that they won't grade, so we can add things to it if we want to. We've got another tension going this way, and then we have mg going straight down. So here's our mg. Here is our T, and then remember this one we're calling TH. Obviously there's some things that we can do to this. We can go back and let's put in that 30 degrees that's right here. And if we do that, we notice that we have two components. One of them is T times the cosine of 30, and one is T times the sine of 30 degrees. The adjacent side, always cosine. Opposite side of the angle is always sine. So we've got T cosine of 30 and T sine of the 30. And they want us to find the tension in the horizontal string. So this should be pretty simple to do. Let's go through and just kind of check all of our forces. So we're going to say sum of the forces in the y direction. So let's go ahead and define this positive y. And we want to define this as positive x. And that is equal to 0. Why is it 0? Because it's not moving, so there's no acceleration here. We have in the y a couple things. We have t cosine of 30 going up, so we're going to say t cosine of 30 degrees. And that should be equal to, so we've got this minus mg is equal to 0. So t cosine of 30 degrees is equal to really just the weight of that mass. The other thing we need to do is say sum of the forces in the x direction is equal to 0. We've got two forces in the x direction. The one going to the right is the horizontal tension minus t sine of 30, which is the angle there, and that is this component of the tension, and that's equal to 0. So at this point, the horizontal tension is equal to T times the sine of 30 degrees. Alrighty, so now that we have that, let's go ahead and solve this side for T. So we're going to say this is T is equal to mg all over the cosine of 30 degrees. If we know that this side is mg over cosine of 30 degrees, so let's make this more 30 degrees here, 30 degrees. We can substitute that in for this t, and then we're able to solve for what we want. So let's go ahead and do that. We'll change colors here. So the tension in the horizontal string is equal to the tensions, well, we said that's mg over cosine of 30 degrees. And then we're going to multiply that times the sine of 30 degrees over 1. So really what that gives us in the end is mg times the sine of 30 degrees over the cosine of 30 degrees. And if we remember correctly, we know sine over cosine is tangent, so that's mg times the tangent of 30 degrees. So now we can go ahead and just solve for what we have. M is 1.8. Our gravity is 10. And we then do the tangent of 30 degrees. And if you solve that, you should come out with something very, very close to 10 newtons. So let's actually put this down here where you can see it a little bit better. So your answer for that horizontal tension should be somewhere around that 10 newtons. And I think for this problem, we are done. Yep, that's it.